Hey guys, it's your boy Derek here, and this is a video for solving quadratic equations by graphing. Okay, so for this video, you guys, if you haven't figured out how to graph quadratic functions part 1 and 2, you need to go back and do that. Otherwise, you won't be able to do any of this. So make sure you know how to graph quadratic functions, especially if they are in vertex form. Okay. So the first steps, here are your steps for doing this. So here's an example of a quadratic equation right here. Okay, so I have it in vertex form. We can point out our vertex right away, hopefully from this. We have our A value right here. That's going to tell us just kind of how skinny this graph is, or how, maybe how a little bit fatter the parabola might be. But we know it's a quadratic because it has this square here. Okay, so it's definitely a quadratic because the highest degree is the power of 2. Okay, and the difference is now instead of equal to y, it's equal to 3. So what we need to do is we want to solve this equation, figure out what values for x are going to satisfy this particular equation. So what we do is we graph the function normally. Okay, so we're still going to graph 2 times x minus 2 squared. Okay, but instead what we're going to do is we're going to treat it as if it's like a system of equations. So we're going to pretend, because normally it's y equals 2 times x minus 2. So what we're going to do is we're going to treat it like it's this. And then what we did is we're taking this y and we're replacing it with 3. So y is also equal to 3. This is my system, because what I did is I just took this 3 here, and I'm just substituting it into my equations right here. Okay, so I'm going to graph the solution of the equation as a horizontal line. Okay, so I'm going to graph the solution of the equation. So this is what I mean by the solution of the equation, as a horizontal line. Okay, so that's the system I'm talking about, because y equals 3 would give me a horizontal line. There'll be this one right here at 3. And then I'm going to use the x values at the intersections as my solution. So wherever this horizontal line crosses my parabola, the x values right here are my two solutions, would be my solutions for this particular equation. Okay, so treat it like it's a system. Graph your function as normal, and then whatever it was equal to, that solution, we're going to use that as a y equals whatever that is, because it's really replacing the y here. And then we're going to graph it like it's a system. Okay, let's look at some examples. So I have the equation 2x squared equals 8. Okay, yes, we will eventually work on it, solving these algebraically, but for right now, let's work on just solving them graphically. So what I want to do is I'm going to treat this like it's a system of equations. Because 8 replaced my y, I also want to graph y equals 8. Okay, so I'm going to graph 2x squared, and I'm going to graph y equals 8. Okay, so the first thing I need to do is I need to just worry about graphing 2x squared, and I need to do it the correct way. So I need to find my vertex still, and then I need to check points on each side of my vertex to make sure I graph it properly. So if I have 2x squared, my vertex is 0, 0. Hopefully we see that right away. There is no h value, there is no k value. Okay, so my vertex is just 0, 0. So now what I can do is I can pick let's just go two points to the right of 0, 0. And let's graph the 2 points to the right. So I need to graph when x is 1 and when x is 2. So if I have 2 times 1 squared, that's going to be 2 squared, because that's going to give me 2 times 1, because 1 squared is 1. Okay, and then I still bring down my 2. And 2 times 1 is just 2. So for 1, I'm going to have 2. Okay, there's my point, but it's symmetrical on both sides. Okay, now I'm going to do the same thing for when x is 2. So I have 2 times 2 squared. This is 2 times 4, because 2 squared is 4, which is going to give me 8. So 1, 2, 3, 4, 5, 6, 7, 8, and it's symmetrical on the other side. There's my parabola for this particular function. Now what I can do is I get to graph my solution, y equals 8. Okay, and I'm going to do that with a different color here. And y equals 8 is just a horizontal line at 8. And so, here, let me even switch it up a little bit here. I'll go back. Try to make a straight line, but it's not bad. So y equals 8, there's my line for y equals 8 right here. Okay, so now we can see where my line y equals 8 crosses my parabola. Okay, and it would be at these 2 points right here. These are my 2 points of intersection. And what are my values of x at those 2 points of intersection? Well, here, x equals -2. And here, x equals 2. So I have two solutions to this equation. X equals +2, and x equals -2. Okay, so x equals plus or minus 2. Now, you can always go back and plug in those solutions to your equation and make sure it works. I can go back and plug in 2 times 2 squared and see if it equals 8. Okay, well, that's what we just did, and it does equal 8. I can plug in -2 here and see if it's going to give me 8. Okay, and if I plug in -2 here, it will give me 8 because -2 squared is still positive 4, so I'm still going to get the same thing I had before. So my solution works. I'm done. So I got another one. So this works for any type of graph. So now I have a little shift here in my graph. That's okay. It's got a fraction in the front. That's fine. I'm still going to graph this piece. Okay. And then I'm going to graph this separately. Okay. So this is the same thing as y equals 2. Here's my system of equations. And I don't even need this piece anymore. Okay. So first I need to graph my actual function. And so first I need to find my vertex. And so it shifts to the right 2, but it does not go up and down. So there's my vertex. And then now I get to worry about the value in the front. And so I've got to graph the x values that are next to my vertex. So I'm going to graph the values 3 and 4. So if I graph 3 and 4, those are symmetrical to the left side. So when I graph 3, let's just plug it in. 3 minus 2 squared. We get 1 squared times 1/2. I always do the parentheses first. Now I do my exponent, and I get 1/2 times 1, which is just 1/2. So when x was 3, my y was 1/2. So, and the left side is symmetrical. Let's go ahead and plug in 4. So if I have 4 minus 2 squared times 1/2, that's going to give me 2 squared times 1/2, which is going to give me 1/2 times 4, which is going to give me 2. So I have 4, my x values are 2. I'll go ahead and stop there, and then there's my parabola. So it's a little bit fatter. Now, I also have to graph the second part of my solution, which is y equals 2. So at y equals 2, that's going to be right here. And I can see my 2 points of intersection right here. 1, 2. Okay, and at those 2 points of intersection, I have x is equal to 0. Because x is 0 at this point. And right here, I've got x is equal to 4. So my solutions are 0 and 4 to this particular equation. And I can plug them back in and make sure that they work out. And I'm telling you guys right now that they do. Okay, so one quick thing I want you guys to know, in solving a quadratic equation, you have the possibility of 1 solution, 2 solutions, or no solution. Okay, so let's make sure we get that down. Let's talk about why. So if this is my, right here, if this is my quadratic function, okay, this is my horizontal line, and this is what it's equal to. If I move this around, right now I still have 2 solutions, 2 solutions, 2 solutions. But if my horizontal line, when I graph, if it's at the vertex, that's only going to be 1 solution. That's going to be your vertex. And then if it's below it or above it, then that means you don't have a solution to that particular equation. There is no values for x that would satisfy that equation. Okay, so depending on what you get, you can get 2 solutions, 1 solution, or no solutions. Okay, let's do one last example. And before this last example, I would like to tell you guys a nice quick little joke. So what happened when the quadratic function fell asleep at the beach? It got 2nd-degree burns. Boom. All right, moving on. So last one, we've got the equation -2 times x minus 3 squared plus 2 equals 3. So a lot going on here. We know we can identify right away that it is quadratic, and that's because of this. The highest power is squared. Okay, that's that 2nd-degree burn right there. Okay, so we know it's a quadratic function. We have an equation because it's not equal to y, it's equal to 3. So what we can do is we can replace this 3 with a y right now if we wanted to. So we can just graph this. But we also know that we have to graph the part y equals 3. Okay. So let's go ahead and just graph our equation normally. So I got to first identify my vertex. It's going to be, let's see, +2, and then right 3, 1, 2, 3. Okay, so there's my vertex because it shifted up 2. It also shifted to the right 3. Now I also look, my graph's going to be opening down. okay, because it's -2 here in the front. So because it's negative, I know my parabola is going to be opening down. And so let's just graph some of my points here. So if I know I'm at 3, let's graph 4. So if I plug in 4, some of you might see a pattern here when you graph your first value, but we'll talk about that pattern right now. When I plug in 4, I have 4 minus 3 is going to give me 1. So every time you plug in the point right next to your vertex, you're always going to end up doing 1 squared times that a value on the outside. Okay, so really what it's always going to do, it's always just going to have you move like a slope, whatever the value, whatever this is, just for that very first point. It's going to give you that. This is like your slope for the very first point. Okay, so because my slope's -2, it's really just going to go down 2 and over 1. I can tell you guys that right now, but let's double check to make sure I'm right. It only works for the first point. Now I can't use this as a slope anymore, and that only happens just because whenever we plug it to the x value next to our vertex, it's always going to give us 1 squared inside our parentheses, which leaves us with this slope. But let me show you why again. And so now when I simplify this, I get 1 times -2 plus 2. This is going to give me -2 plus 2, which is 0. Oh, look, and I was right when I used it as a slope. I'm sorry, that's plus 2, which is equal to 0. So when x is 4, my y is 0. When x is 2, my y is also 0 because the left side is symmetrical to the right side. I'm going to stop here. Normally when you guys graph parabolas, you should graph multiple points on each side. But just to make this video a little bit shorter, I'm going to stop there, and I'll show you guys why. I kind of looked ahead and I saw that my value for my y value was 3. And so I kind of can see that when I graph y equals 3, right away I'm going to be at 1, 2, 3. Isn't that above what my vertex was at? So that horizontal line right here is above my vertex and the graph is opening down. So therefore there is no solution. So that's why I didn't want to go too far into graphing that particular parabola. There's no solution to this. Okay, because 3 is above the parabola and it's not intersecting at any point, there's no solution. All right, that's it for this video, guys. I hope this video helped. If you have any questions, please let me know, and good luck.